Hi, I chose the topic of brown bear spring energetics in Alaska, specifically comparing net body mass between two populations, Kodiak and Gates of the Arctic bears, circled on the map in red. I'm interested in Alaska's wildlife because it's ecologically vital and personally fascinating. Studying brown bear body mass links my biology interest to conservation and prepares me for a future career. A literature review related to my research details a method for estimating brown bear populations and harvest rates on the southern Alaska Peninsula. Accurate data are vital for sustainable management given bears' slow reproductive rates and vulnerability to overharvest. The research highlights the importance of physiological indicators such as net body mass for monitoring bear health and the status of bear populations, supporting conservation efforts in key areas such as Kodiak and the Gates of the Arctic. Comparing traits among Alaskan populations enables managers to assess regional differences in population dynamics and inform strategies for long-term sustainability. My research question was, is there statistically significant difference in the mean net body mass between female brown bears and the Kodiak population and those from the Gates of the Arctic population? The hypothesis stated is that there is a statistically significant difference in the mean net body mass between female brown bears from the Kodiak population and those from the Gates of the Arctic population. Pictured is a Kodiak bear paw in comparison to a person for reference. The data set I used includes an equal number of 14 bears from each population, totaling 28. It covers spring body composition, energy, content for adult female brown bears from several populations across Alaskan regions, including Gates of the Arctic and Kodiak. Data was collected in the spring from 2014 to 2017. Female bears were live captured and net body mass was measured. Body composition was assessed through morphometric measurements, bioelectrical impedance, or isotope dilution, along with laboratory analysis for energy contents. The dataset is part of the USGS Brown Bear Spring Energetics Project in Alaska, and it is available at sciencebase.gov. Here you have the calculated descriptive statistics and histograms for the Kodiak bear data and Gates of the Arctic data. The 95% confidence intervals for the mean net body mass indicates that Gates of the Arctic bears have an internal of 81.85 and 99.37 kilograms, while Kodiak bears have an interval of 166.74 and 199.38 kilograms. Because these intervals do not overlap, we can conclude that there is statistically significant difference in the mean net body mass between female brown bears from the Kodiak and Gates of the Arctic populations. This means the average body mass for Kodiak bears is higher than for Gates of the Arctic bears, with confidence based on the data. Showing the hypothesis results, test used, t-test assuming unequal variances. Test statistics, 10.7849. The p-value was 0.0. And since the p-value from the t-test is 0.0000, which is much smaller than the significance level of 0.05, I reject the null hypothesis. This result provides strong evidence of a statistically significant difference in mean net body mass between the Gates of the Arctic and Kodiak female brown bear populations. Based on the results of the two-sample t-test, there is a strong statistical evidence that the mean net body mass of female brown bears in the Kodiak population is significantly greater than in the Gates of the Arctic population. The p-value is much less than the chosen significance level of 0.05, so the null hypothesis of equal means is rejected. This supports the conclusion that Kodiak bears have a substantially higher average net body mass compared to Gates of the Arctic bears in the measured samples.